Look up at the night sky, what do you see? A dazzling tapestry of stars, each one a distant sun. These celestial objects are more than just points of light. They are the building blocks of galaxies, the engines of cosmic energy, and the cradles of life itself. Stars have a life cycle just like living things. They are born, they mature, and they eventually die. But unlike the fleeting lifespan of humans, a star's life unfolds over millions, billions, even trillions of years. Understanding the life cycle of stars allows us to trace the origins of our own existence. The very atoms in our bodies were forged in the fiery hearts of stars long gone. We are, quite literally, stardust. So let's embark on a cosmic journey to explore the fascinating story of stars, from their birth in interstellar clouds to their explosive deaths and the profound legacy they leave behind. Stars are born in vast, cold clouds of gas and dust scattered throughout galaxies. These clouds, known as stellar nurseries or nebulae, are the cosmic wombs where stars first ignite. Imagine a nebula as a giant cosmic recycling bin filled with the remnants of dead stars. Gravity is the driving force behind star formation. Within a nebula, clumps of gas and dust begin to collapse in on themselves under their own gravitational pull. As this material falls inward, it spins faster and faster, like a figure skater pulling their arms in during a spin. The core of this collapsing cloud heats up as gravitational energy is converted into thermal energy. This hot, dense core is called a protostar. It's not a star yet, but it's well on its way. As the protostar continues to accrete material, its core temperature and pressure increase dramatically. Eventually, the core becomes so hot and dense that nuclear fusion ignites. Hydrogen atoms fuse to form helium, releasing an incredible amount of energy. A star is born. Once nuclear fusion begins, a star enters the longest and most stable phase of its life, the main sequence. Our own Sun is a main sequence star, and it will remain in this stage for billions of years to come. During the main sequence, a star exists in a state of equilibrium. The outward pressure from nuclear fusion in the core perfectly balances the inward pull of gravity. Think of it like a cosmic tug-of-war, with both sides equally matched. The color and brightness of a main sequence star depend on its mass. Massive stars are hot and blue, burning through their fuel quickly. Smaller stars, like our Sun, are cooler and yellow, sipping their fuel slowly over billions of years. Red dwarfs are the smallest and coolest main sequence stars. They are incredibly fuel efficient and can live for trillions of years. Blue giants, on the other hand, are massive and short-lived, exhausting their fuel in a cosmic blink of an eye. Eventually, every star runs out of hydrogen fuel in its core. When this happens, the outward pressure from fusion lessens and gravity takes over. The core contracts and heats up, while the outer layers of the star expand dramatically, becoming cooler and redder. The star has entered the red giant phase. Imagine a campfire. As the wood burns, it eventually forms a pile of hot embers. These embers are like the contracting core of a red giant, while the expanding, cooling flames resemble the star's outer layers. Red giants are enormous, often hundreds of times larger than their main sequence counterparts. If our Sun were to become a red giant, it would engulf the orbits of Mercury, Venus, and possibly even Earth. As a red giant continues to evolve, its core becomes a cosmic pressure cooker. Helium, the byproduct of hydrogen fusion, begins to fuse into heavier elements like carbon and oxygen. Section 5. The stellar graveyard, white dwarfs and supernova. The final stages of a star's life are determined by its mass. Smaller stars, like our Sun, will eventually shed their outer layers, leaving behind a dense, hot core called a white dwarf. Imagine a white dwarf as a cosmic ember, slowly cooling down over billions of years. They are incredibly dense, packing the mass of the Sun into a sphere roughly the size of Earth. White dwarfs eventually fade away, becoming black dwarfs. Cold, dark remnants of once bright stars. Massive stars, on the other hand, are destined for a far more dramatic end. Their cores continue to fuse heavier and heavier elements until they form iron. Iron fusion consumes energy instead of releasing it, marking the beginning of the star's demise. When a massive star can no longer sustain nuclear fusion, gravity wins the ultimate battle. The core collapses in on itself, triggering a catastrophic explosion known as a supernova. Section 6. Supernovae, the universe's grand finale. Supernovae are among the most violent and energetic events in the universe. For a brief moment, a single supernova can outshine an entire galaxy, releasing more energy in a few seconds than our sun will emit in its entire lifetime. Imagine a supernova as the universe's grandest fireworks display. The explosion blasts the star's outer layers into space at incredible speeds, seeding the surrounding interstellar medium with heavy elements and creating stunning nebulae that can span hundreds of light years. Supernovae are not just destructive events, they are also essential for the evolution of the universe. The intense energy and pressure during a supernova create elements heavier than iron, such as gold, silver, and uranium. These elements, forged in the heart of a dying star, are scattered throughout the cosmos, eventually becoming part of new stars, planets, and even life itself. Section 7. Cosmic alchemy, the creation of elements. Stars are cosmic alchemists, transforming simple elements into heavier ones through the process of nuclear fusion. This stellar alchemy is responsible for the diversity of elements we see in the universe today. Imagine the core of a star as a giant cosmic pressure cooker. Intense heat and pressure force atomic nuclei to overcome their natural repulsion and fuse together. Hydrogen, the simplest and most abundant element, fuses into helium in the core of main sequence stars. As stars evolve, they fuse helium into carbon, carbon into oxygen, and so on, creating heavier and heavier elements. Each stage of fusion releases energy that powers the star and prevents it from collapsing under its own gravity. This process continues until the core is primarily composed of iron, at which point fusion no longer releases energy. Section 8. We are stardust, the legacy of stars. Supernovae may seem like distant, violent events, but they are intimately connected to our own existence. The elements forged in the hearts of dying stars are the building blocks of everything we see around us. The iron in our blood, the calcium in our bones, the oxygen we breathe. All were created billions of years ago inside stars that lived and died long before our sun was even born. We are not just observers of the cosmos, we are participants. The atoms in our bodies have been recycled countless times, forged in stars scattered by supernovae, and incorporated into new generations of stars and planets. The next time you look up at the night sky, remember that you are witnessing the life cycle of stars playing out across the universe. And those stars, in a very real sense, are your ancestors. Section 9. The ongoing cycle of stellar evolution. The life and death of stars is not a one-time event, but a continuous cycle that has been repeating for billions of years. Supernovae enrich the interstellar medium with heavy elements, providing the raw materials for new generations of stars and planetary systems. Imagine the universe as a vast cosmic garden with stars as its plants. Just as plants draw nutrients from the soil, stars form from the enriched gas and dust scattered by previous generations of stars. This ongoing cycle of stellar birth, life, and death drives the evolution of galaxies and enriches the chemical complexity of the universe. Without stars, the universe would be a very different place, devoid of planets, life, and even us. Section 10. Conclusion, our starlit heritage. Stars are more than just points of light in the night sky. They are the fundamental building blocks of the universe. They are the engines of cosmic energy, the creators of heavy elements, and the ultimate source of our own existence. By understanding the life cycle of stars, we gain a deeper appreciation for the interconnectedness of the cosmos and our place within it. We are all products of stellar evolution, born from the ashes of dead stars and connected to the universe through the grand cycle of cosmic birth, life, and death. So the next time you look up at the stars, remember that you are gazing upon our own cosmic heritage. The universe is not a distant, indifferent entity, it's our home, and we are all made of stardust.